Good morning everyone, and welcome back to our tutorials on turning and programming. Today, I can't really say ISO programming anymore because I want to dive into the use of Manual Guide, which is a conversational software for programming machine tools, almost without knowing ISO. Because if you don't know ISO, in my opinion, you won't get anywhere. However, in theory, conversational programming was created so you wouldn't have to know it. That said, it's a tool that works well for single-piece production. I can tell you that in my professional life, as you know, I was a craftsman working in high production. I never used conversational programming. To be honest, I only used CAM to figure out certain points that I struggled to calculate. But in reality, when you're doing high production, ISO is unbeatable because it allows you to fine-tune the program down to the smallest details and optimize production times. But when someone is making a single piece, one piece, two pieces, at most 10 pieces, where do they waste time? They waste time just creating the program. Here, the Manual Guide, the conversational CAM, and all those technological tools that we have available today come to our aid and give us a great help. The first time you pick up a conversational, your first thought is, it's no use, because with ISO it's quicker. Then you learn and you understand that there are actually advantages. So today, let's focus on this piece I've placed here and mainly think about the external turning of this piece. So first of all, let's create a new program. Let's go to the list, create a new program, and we'll call it OSOZOZO1. So let's try to understand right away that Manual Guide doesn't allow us to do whatever we want. It imposes certain preset paths. So the first thing to do is, in the Manual Guide, establishing my raw material is crucial. We work a lot with the soft keys, which are these little buttons we find down here. In the raw material start procedure, we can input 4 types of raw materials: a parallel piped, a cylinder, a tube, or a prism. The first limitation is that we can't draw the raw material. So if we start from a cast piece, the Manual Guide will crash. But if someone is making 1 piece, 2 pieces, or 10 pieces, they will never start from a cast piece. They will start, for example, from a cylinder or a cut-off piece purchased from the supplier, full of the material requested by the customer. So we select the cylinder, and we've already seen this. We have an outer diameter of radius 50, so 100. Let's say we can take it here. We can do half on each side, and we've already made the external grip. We've worked the piece up to here, and we want to work on this area, so our grip will be roughly here. Let's ignore that we're a bit too cantilevered and focus on what we need to make the machine do. So diameter 100, length 102, K2. K, as we know from the other tutorials, is the protrusion of the piece relative to the 0 point. We will input that and think about the first operation we want to perform. First of all, we need to clear out this entire area, or possibly drill inside the piece. Let's say that I have always told you that the most difficult operations are those that need to be done first. In this case, I would drill first and then think about roughing. We have a 32 mm hole, so we use a 32 mm bit. Check the tool compensator table, essential for the process. A bit is on compensator 11. T11 bit radius is 3. So let's go to our tool compensator table, because it becomes an integral part of the process. The manual guide can't run a cycle if it doesn't know what tool will be used. So let's check where I already have a bit on compensator number 11. I already have a bit set up this way. Let's just tell the machine that it's an insert bit, so the head angle is 180 degrees. Now let's check the diameter of the T11 bit. The radius is 5, but actually it will be a radius of 3, 16. So diameter 32, virtual point 0. The tip 1 is perfect. So let's close the tool correctors page and go to insert our corrector. T11, 11, and insert. Rather, we work with soft keys, excuse me. We delete this T11 working with soft keys. Here too, we have this, which is the turning manual guide page. You see that it is the round piece. Otherwise, there is the milling manual guide page. You see that we have a square icon. So here we have the raw start procedure, the cycle, the figure, M code, formats. M code is just, let's say, a reminder. Fixed format, a fixed format that is customizable on a standard machine, but in this simulator, it allows you to input all at once what could be the formats for moving the tailstock or the live center. In our case, our simple fixed format is the tool. Change for the lathe, so I enter it, and you can see it gives me 3 lines. 2, fill out, 11, 11, alter, and the tool. I want to work at a constant cutting speed. Since we're doing a single piece with conservative parameters of 160 meters, and I want to rotate my spindle in M4. These don't concern us. As I said, I would customize it differently. Now let's talk about the first cycle. You can see we have quite a few options here. Turning, groove turning, threading, drilling. We want to do a nice central drilling, so let's double click. Pass depth, make a long hole, at least 60. Return passes are for chip removal. Set to 60 to avoid return, or 20 for return. How far should the tip go beyond the hole? None, due to a flat insert tip. Safety distance is 5 mm, feed rate is 0.13, and dwell time is at least 0.1 seconds. In short, how far do you want the tip to go? Beyond the actual hole? Nothing, because we have a flat insert tip. Safety distance is 5 meters. Feed rate of the tip is 0.13, and the dwell time at the bottom should be at least 1/10 of a second. As we approach it, we come in with 2 axes. You see, there's no choice here. I repeat, real machines are a bit more customizable. The base position is where I start drilling, from 0, Z0. So, I set it to 0. Input the length. We might look at that later. It always goes negative, so -50. Enter. This is the initial depth. Now you want the drill bit to enter smoothly for the first 5 mm. We set a feed rate of 0.13, but I want it to start at 0.06 per revolution for the first 5 ms. Excuse me, the first 5 ms at 0.06 per revolution. And at the end, because in this case I'm crossing another hole, I want the last 5 ms to also exit at 0.06. I said 0.06, but I set it to 0.05 just because I mentioned it. Let's modify that, so the last 5 meter dropped the feed rate back to 0.06. Enter. So as you saw, it asked me for a feed rate of 0.13, but for the first 5 millimeters attack it at 0.06, and for the last 5 millimeters exit at 0.06. Let's insert that. We've inserted it. Now let's try to simulate it. It will give us an error because there's no M30. Or let's put that in and see if we did everything correctly. This is how we do it when building houses. Status of work progress. Simulate. Sorry, let me turn it around. You see that we made the hole. And here, there's nothing about ISO. Okay, let's go back to our program. And now, let's start thinking about actually turning. So, now let us indeed change our tool. I already know that in position 1, I have a tool in the correction table. Let's check the corrections for an external tool. Mounted in this position, clearance angle 95, angle 20 degrees. We're working on something like this. It will need to be worked with a CNMG. In this case, it wouldn't give us any errors, but just to be thorough, we'll write it down and close it. Perfect. Look, even I make mistakes, you know. I had a tip working in G96, but tips actually work in G97. Alter S800. Alter, which means 800 fixed RPM. Okay. Because I had turning on my mind, I apologize. But now that we're doing the turning, we need to set those parameters I had in mind earlier. G96, S160, M4, EOB insert. Tips always work in M3. And I apologize again, but I have in my head what I need to explain. And sometimes I get confused. I mean, errors and misjudgments happen. So, let's proceed carefully. Alright, let's now get started with the interesting part. Here too, we need to insert a cycle. Here they are, all the turning cycles. Rough external turning, rough internal turning, front roughing, and possibly chamfering, semi-finishing external turning. Be careful. There's also outer turning. This wasn't introduced, I don't know why. Outer row, external roughing, plus finishing. But it needs to be done with the same tool. What's the point of having roughing and turning with the same tool? It's probably that being aimed at those who make one or two pieces, the wear of the tool is relative. I do the turning and finishing for you with 2 different operations and more. For the simple purpose of being a bit more educational, external turning and roughing, double-click. In your case, it will be an enter. Cutting direction, where do we want to work it? From Z plus to Z minus, so the cutting. Direction is Z minus. Radial depth of cut, okay? So for every roughing operation you do, it will lower by 5 meter radially, so 10 meter. You can change it. If you want to set it to 4, just delete and write 4 live. You can adjust it however you like. However, this is a fixed value. The approach feed depth is set at 100%, and it cannot be modified. You can change it however you like. On the other hand, this is a figure where the approach feed depth is set fixed at 100% and it cannot be modified. Excess material. In finishing, on the x-axis 1 meter. Excess material in finishing on the z-axis 1 mm. Cutting feed speed 13 mm per revolution for roughing is fine. Then you have the depth for entering and exiting. If you're making pockets, be careful. When you create pockets, you need to select a tool that allows you to make that specific pocket. First adjustment here, K100 is not modified. It can't be changed. The tool's lift is also not adjustable. As you can see, you only have one option. Sorry, it can't be modified. I wanted to check that for you. It's not actually adjustable. The retraction distance is 1 millimeter, meaning every time the tool roughs, it lifts by 1 millimeter in the X direction. There are safety distances in X and safety distances in Z for approaching the two axes. This also can't be modified, but actually, when purchasing the machine, you can add soft keys. The direction of the cutting movement, that is, whether you rough from the inside out or from the outside in. In our case, it's from the outside to the inside. So the cutting direction will be X for pocket cutting. Delete or cancel means if there are pockets, do you want the software to ignore them because you have a pocket unsuitable for your tool? Or do you want it to create them? We don't have pockets, so if you don't want them to be created, put null. If you want them to be created, put cut. This is also not available with or without facing. Meaning, do you want it to start facing before roughing the piece? In this simulator it's not available, but in the controls you will probably have at the company. It will be available. You can face first, which is always the best option. We've entered the machine, but it takes you directly back to this turning menu in the ZX plane. Here's the interesting part. We need to draw the profile. Let's go back to the machine. For now, we've only set the parameters. Okay? Machine, the technological data. Now we need to tell it what path to take. You see the diameter here is 40, but we drilled with a 32 drill bit. So we start with a smaller diameter, X28. Okay? And we have the first point. We start from here. Now we need to draw it. So, let's insert a line. Let's go into this menu for the line direction. I want to go upwards. Okay, we're at 28. I want to go to X50. Where do you want to get? 2. X50. Enter. Okay, and you can see we have a line that goes from 28 to 50. Here we see our X. How do you want it to end? I want it to end with a chamfer of 1 millimeter. Okay? You see it hasn't drawn it because I haven't told it yet where the next line will be. Direction left, endpoint, Z15. Okay. It drew the line at -15 and raised it to diameter R30, which is 60. I need an X60. Add a 1 millimeter fillet since the drawing doesn't specify. No direction given. Line left. It's a groove cycle. Drawing it will stick in CNMG. End at -90, 100 minus 10. The piece is taking shape. Enter. Okay, built as I want. How do I want it to end here? This time, since the drawing doesn't specify anything, let's add a fillet of 1 millimeter. Enter. Okay, you see it hasn't drawn it because I haven't told it yet which way to go. Line left. Be careful. I'm not drawing this because for it, this is a cycle of grooves. If I draw it, it will get stuck in my CNMG. So I'm going to end up in this area, -90. We have 100 minus 10. Okay, you see the piece is taking shape. At this point, I have a rough piece with a diameter of 105. I'm coming out of my rough piece, so line upwards. Actually, let's also add a chamfer here. Let's say we only take it up by 5 to 6 mm because we're good at this. And we also make a chamfer, so we arrive at a diameter of 100. We have 100 minus 10. Okay. Do you see that the piece is taking shape? At this point, I have a rough piece with a diameter of 105. I'm coming out of my rough piece, so line upwards. Actually, let's also add a chamfer here. Let's say we only take it up by 5 to 6 mm because we're good at this. And we also make a chamfer, so we arrive at a diameter of 100. Okay, let's make this chamfer small. this chamfer, okay? And let's draw a line, but I want it to not be completely straight, since we have a diameter of 100 here. Okay, let's just make this chamfer slightly small. This chamfer, okay? And let's draw a line, but I want it to not be completely straight. Since we have a diameter of 100 here, a bit more detail is needed. Raise the lathe by a couple of tenths and move it over just 2 millimeters. So, a line. To the left but going upwards. I need to open the request for both an X and a Z, and if needed, also for the angle. Initially, we had set the value for X at 100, but now we are adjusting it to be 0.5. Similarly, for Z, we are making a change by reducing it to -92. This adjustment is crucial for our calculations and overall results. Be careful with the angles, I don't need them here. How are the angles viewed exactly in this context? From different perspectives. The corners are seen by opening in this direction. So if we want to go down, we will have to write 90. Then we'll look at this topic closely, because the manual guide sees the angles differently than the lathe. Let's take it step by step. Perfect. Now the machine needs something else, because I would have finished. Look at this icon here. It asks me to close the shape, because there are two options for closing it. The shape can be closed this way. Okay, and it would clash with an internal operation, or an external operation. Or it can be closed this way. See, and it fits with an external operation. In short, it's asking me if the selected raw material is connected, meaning it makes sense that we are removing this area. Of course it makes sense. So perfect. Do you want to insert it into the current program, or create a subprogram? Let's insert it into the current program. Otherwise, we could create a subprogram with its own name and use it for any other operations. Okay, perfect. What happened here? It has inserted all this stuff, which is its way of seeing and describing the piece. Let's go into simulation. Okay, we insert it into the current program. Otherwise, we could create a subprogram with its own name and go and use it in any other processes. Okay, perfect. What happened here? He carefully inserted all of this additional stuff, which is his unique and thoughtful way of seeing, understanding, and vividly describing the intricate details of the piece. Now let's proceed into the simulation. Okay, I don't know if you noticed, but we went back to programming, and we inserted the cycle, which then took me to this menu here, which was just this, the shape. Okay, when we inserted the cycle, it added this line from G1120 to N1. When inserted the shape, he inserted from this block. Look, you can see it. You see that as I highlight a block, we move forward. Perfect if I want to. Now, perform just the finishing of all this mess here. All I have to do is highlight this block. Copy it. I copy it where? Until the end, I carefully copy it. I bring it here meticulously. I paste it, and now I insert a finishing tool, which in this case can be the T0303 with some finishing parameters, ensuring accuracy and correctness. And first, at this point, I'm going to insert the cycle with precision and attention to detail, step by step, in every step of the process, to achieve the desired outcome. What cycle? An external finishing cycle. I click here. It asks me for Z, which is the cutting direction. I will work in this direction. So Z, feed rate F02, safety, distance 2 mm in both Z and X, approaching, 2 axes, cutting direction, Z plus, X plus, because I'm starting from a small diameter to reach a large diameter. We can ignore the pocket cutting here. Let's insert it and cancel it because I've already redefined the piece's design. If I were to redo it, I would end up with 2 pieces. In this case, I copied exactly what I did for the roughing, so I'm more than good to go. Simulate, restart. Let's see if I actually have a suitable tool in tool offset number 3. In tool offset number 3, I have a generic tool. Perfect. Close, and there we have inserted roughing and finishing through the manual guide without knowing anything about ISO code except for the tool change. Well, I would say that for now I'll stop here. Next time maybe we'll look at that ball and the roughing and finishing. The interior, I apologize if I stumble a bit sometimes, but it's a very fascinating topic, although quite complex in terms of the data to be input. However, I've already noticed that once you understand the logic, all the other operations, whether it's internal cross-hatching, external cross-hatching, or finishing, follow the same concept. So if you understand one, you can understand them all. I hope you enjoyed this tutorial and found it interesting. If you liked it, subscribe to the page, give it a thumbs up, and share it on your social media. If you didn't like it, just pretend you didn't see it. Thank you. See you next time.